10 kilowatts generator size evaluation shows that the 10 kilowatts generator provided by the plumbing supplier does appear to be oversized for the specified steam sauna shower. Here's a breakdown. Firstly, the heat output. 10 kilowatts equates to approximately 34,000 British thermal units per hour, which is a significant amount of heat. Secondly, the sauna size. The sauna is relatively small at 3 feet by 5 feet by 7.5 feet. A smaller space typically requires less heat to reach the desired temperature. Thirdly, insulation. The insulated walls, floor, and ceiling help to retain heat, further reducing the required heat output. Fourthly, glass walls. Glass does not provide as good insulation as insulated walls, but it is still a significant factor in heat retention. Some electrical concerns are that the 200 amps main service may indeed be insufficient to accommodate the 10 kilowatts generator, especially if the guest house also draws power from it. Here's a rough calculation. A 10 kilowatts generator equals 41.67 amps. A guest house load is estimated at 50 amps. Total load is approximately 92 amps. This exceeds the capacity of a 200 amps main service, which is typically rated for 80% of its capacity, which is 160 amps. Some control concerns are that controlling the temperature in a sauna with such a large generator may be challenging. A 10 kilowatts generator will quickly heat the space to a very high temperature, making it difficult to finally adjust the desired comfort level. Based on the information provided, it would be advisable to firstly reconsider the 10 kilowatts generator. Secondly, consult with a sauna expert or the manufacturer to determine the appropriate size for the sauna. Thirdly, calculate the total electrical load. Fourthly, determine the current load on the 200 amps main service and the anticipated load from the sauna and guest house to assess the need for an upgrade. Fifthly, discuss options with the homeowner, explain the concerns, and provide alternative solutions, such as using a smaller generator or upgrading the electrical service. It's important to approach this situation in a professional and informative manner, providing the homeowner with all the necessary information to make an informed decision. Some important points to cover are electrical load calculations, determining the appropriate generator size, and control system considerations. To accurately assess the electrical load, perform a load calculation according to the National Electrical Code (NEC). Article 220 covers the requirements for calculating branch circuit, feeder, and service loads. This calculation should include all existing loads in the house, the estimated load of the guest house, and the proposed 10 kilowatt steam generator. For dwelling units, general lighting loads are calculated based on volt-ampere per square foot, as outlined in NEC Table 220.12. Small appliance circuits and laundry circuits are calculated at 1500 volt-amps each, as per NEC 220.49 and 220.16a. Fixed appliances are calculated at their nameplate rating. The NEC allows for demand factors to be applied to certain loads, such as ranges, dryers, and heating and cooling equipment, as specified in Article 220. After calculating the total connected load, apply any applicable demand factors to determine the maximum demand load. This will give you a more realistic estimate of the actual load the service will experience. Compare the maximum demand load to the capacity of the 200 amps service. A 200 amps service at 240 volts has a capacity of 48,000 volt amps. If the calculated demand load exceeds 80% of the service capacity, which is 38,400 volt amps, the service is likely undersized. Article 215.2 addresses the minimum feeder capacity, ensuring that the feeder is of sufficient size to carry the calculated load. If the load calculation indicates that the 200 amps service is inadequate, an upgrade to a larger service, such as 400 amps, may be necessary. The size of the steam generator should be carefully evaluated to match the actual requirements of the sauna. A 10 kilowatts generator may be excessive for a small, well-insulated sauna. Consult with a sauna manufacturer or a qualified sauna specialist to determine the appropriate size. They can take into account the sauna's dimensions, insulation, materials, and usage patterns. A smaller generator will reduce the electrical load and may eliminate the need for a service upgrade. It will also provide more precise temperature control, enhancing the sauna experience. Steam generators typically require a dedicated circuit. The size of the circuit depends on the generator's power requirements. A 10 kilowatts generator at 240 volts will draw approximately 41.67 amps. The circuit should be sized at 125% of the continuous load, as required by NEC 210.20a, resulting in a minimum circuit capacity of 52.9 amps. Therefore, a 60 amp circuit with number 6 American wire gauge copper conductors is recommended. The circuit breaker should also be rated at 60 amps. Ensure that the wiring method and overcurrent protection comply with all applicable codes and standards. The steam generator should be equipped with a precise temperature control system. This system should allow the user to set the desired temperature and maintain it accurately. The control system should also include safety features such as over-temperature protection and automatic shutoff. Consider using a programmable thermostat that can be set to different temperatures for different times of the day. This can help to conserve energy and provide a more comfortable sauna experience. Evaluate the steam generator's control system to ensure that it is compatible with the sauna environment. The control should be moisture resistant and easy to operate. It is important to ensure that the sauna installation complies with all applicable codes and standards. This includes electrical codes, plumbing codes, and building codes. Obtain the necessary permits and inspections to ensure that the installation is safe and code compliant. Consult with a qualified electrician and plumber to ensure that the installation is done correctly. The NEC provides detailed requirements for electrical installations in bathrooms and similar environments. Article 680 addresses the requirements for swimming pools, fountains, and similar installations, which may be relevant to steam saunas. Ensure that all electrical equipment is properly grounded and that ground fault circuit interrupter (GFCI) protection is provided where required. The location of the steam generator should be carefully considered. It should be installed in a location that is easily accessible for maintenance and repair. The generator should also be protected from moisture and physical damage. Provide adequate ventilation around the steam generator to prevent overheating. Follow the manufacturer's instructions for installation and operation. In addition to the electrical considerations, there are also plumbing considerations to address. The steam generator requires a water supply and a drain. The water supply should be connected to a potable water source. The drain should be connected to a sanitary drain. Ensure that the plumbing connections are properly sized and installed according to code. The steam generator should be equipped with a pressure relief valve to prevent overpressurization. The steam line from the generator to the sauna should be insulated to prevent heat loss. The steam outlet in the sauna should be located in a safe and convenient location. Proper ventilation is essential in a steam sauna to prevent the build-up of moisture and carbon dioxide. Provide adequate ventilation to ensure a comfortable and safe sauna experience. The ventilation system should be designed to exhaust moist air from the sauna. A combination of natural and mechanical ventilation may be used. Install a vent near the ceiling to exhaust hot, moist air. Install a vent near the floor to supply fresh air. Ensure that the ventilation system complies with all applicable codes and standards. Consider installing a humidity sensor to monitor the humidity level in the sauna. This can help to optimize the ventilation system and prevent the buildup of moisture. The materials used in the sauna should be carefully selected to withstand the high temperatures and humidity levels. Use moisture-resistant materials such as cedar, redwood, or tile. Avoid using materials that are prone to mold or mildew. Ensure that the sauna is properly sealed to prevent moisture from escaping into the surrounding areas. Install a vapor barrier behind the walls and ceiling to protect the structure from moisture damage. Inspect the sauna regularly for signs of moisture damage and address any problems promptly. Provide clear instructions to the homeowner on the proper operation and maintenance of the steam sauna. This should include information on temperature control, ventilation, and cleaning. Explain the safety precautions that should be followed to prevent accidents. Provide a maintenance schedule to ensure that the sauna is properly maintained. The homeowner should be aware of the potential risks associated with steam saunas, such as burns and heat stroke. Post warning signs in the sauna to remind users of these risks. Provide a timer that automatically shuts off the steam generator after a set period of time. This can help to prevent overheating and conserve energy. In summary, the 10 kilowatt steam generator appears to be oversized for the specified sauna shower. A thorough electrical load calculation is necessary to determine if the existing 200 amp service is adequate. Consult with a sauna expert to determine the appropriate size of the steam generator. Ensure that the installation complies with all applicable codes and standards. Provide clear instructions to the homeowner on the proper operation and maintenance of the sauna. By following these recommendations, you can ensure a safe, efficient, and enjoyable sauna experience. Remember to prioritize safety and compliance with all applicable codes and standards. Consult with qualified professionals to ensure that the installation is done correctly. By taking a comprehensive approach to the design and installation of the steam sauna, you can provide the homeowner with a high-quality and long-lasting product. Properly sizing the steam generator is crucial for both performance and safety. An oversized generator will consume more energy and may be difficult to control, while an undersized generator will not provide adequate steam. The size of the sauna is a primary factor in determining the appropriate generator size. The larger the sauna, the more heat and steam will be required to reach the desired temperature. The insulation of the sauna is another important factor. A well-insulated sauna will require less heat and steam than a poorly insulated sauna. The materials used in the sauna can also affect the generator size. Some materials, such as glass, conduct heat more readily than others. The desired temperature and humidity level in the sauna will also affect the generator size. The higher the desired temperature and humidity, the more powerful the generator will need to be. The frequency of sauna use should also be considered. If the sauna will be used frequently, a larger generator may be necessary to ensure that it can quickly reach the desired temperature. The number of people who will be using the sauna at one time should also be considered. A larger generator may be necessary to provide adequate steam for multiple users. The location of the sauna can also affect the generator size. Saunas located in colder climates will require more heat than saunas located in warmer climates. The altitude of the sauna can also affect the generator size. Saunas located at higher altitudes will require more heat due to the lower air pressure. The NEC provides guidance on calculating the electrical load for steam generators. This calculation should include the generator's power rating, voltage, and amperage. The calculation should also take into account any other electrical loads that will be served by the same circuit. The circuit breaker and wiring should be sized according to the calculated load. The steam generator should be installed in accordance with the manufacturer's instructions. The installation should also comply with all applicable codes and standards. The steam generator should be properly grounded to prevent electrical shock. The ground fault circuit interrupter, GFCI, should be installed to protect against ground faults. The steam generator should be equipped with a pressure relief valve to prevent overpressurization. The steam line should be properly insulated to prevent heat loss. The steam outlet should be located in a safe and convenient location. The control system should be easy to use and understand. The control system should allow the user to set the desired temperature and humidity level. The control system should also include safety features such as over-temperature protection. The steam generator should be inspected regularly to ensure that it is operating properly. Any necessary repairs should be made promptly. The homeowner should be provided with clear instructions on the proper operation and maintenance of the steam generator. These instructions should include information on temperature control, ventilation, and cleaning. The homeowner should also be aware of the potential risks associated with steam saunas, such as burns and heat stroke. Warning signs should be posted in the sauna to remind users of these risks. A timer should be installed to automatically shut off the steam generator after a set period of time. This can help to prevent overheating and conserve energy. In addition to the above considerations, it is also important to choose a reputable manufacturer and supply. A reputable manufacturer will provide a high-quality product and excellent customer support. A reputable supplier will be able to provide expert advice and assistance with the selection and installation of the steam generator. By carefully considering all of these factors, you can ensure that the steam sauna is properly designed, installed, and maintained, and that it provides a safe, enjoyable, and relaxing experience for the homeowner. Always consult with qualified professionals to ensure that the installation meets all applicable codes and standards.